Guys, Miss Miklos here, and I'm just going to go through a few questions that are going to cover the concepts that you guys need to know for our test this week. So I'm going to go ahead and start off with one of the questions that's going to ask us to solve the triangle. So we're going to focus on number 1 here. And first of all, it asks us to round to the nearest tenth, so I know that that's 1 decimal place. And these problems, I'm going to have to use a combination of law of sines and law of cosines, depending on what information is given to us. So if we look at number 1 here, they give us side A, side B, and angle C. So I know I need to find angle A, angle B, and side C. Based on the information given to us right now, I can only use law of cosines. I do not have enough information to use law of sines at the moment. So I'm going to go ahead and use law of cosines here, and since I'm using angle C, which is 45 degrees, I know I need to put that side all by itself on the other side of the equation. Now this equation's nice because since my variable is isolated, I can put everything else straight into my calculator. So I want you guys to go ahead and do that along with me, just to make sure you're using your calculator correctly. We need to make sure our mode is in degrees since this is in degrees. And when I put that in my calculator, I get something like 40.632 blah, blah, blah. I know I'm not done yet because I need to get C all by itself, so I need to square root both sides of my equation. And I get that C is 6.37, so when I round that to the nearest tenth, I get C is 6.4. So if I'm just using some common sense here, I notice that side C is in between these two side lengths. So that means that 45 degrees is going to be the middle angle. So that means angle B is going to be larger and angle A is going to be smaller. So I'm going to go ahead and start now by finding angle A. And once again, on these problems, it's really important I'm showing all of my work. So in order to find angle A, I'm going to choose to use law of sines because I now have enough information to do that. So I wrote sine of angle A over 6 equals sine of 45 degrees over 6.4. And then I'm going to cross multiply and divide both sides by 6.4. Now in my calculator, since I'm finding an angle, I know I need to use sine inverse. So in my calculator, I'm putting sine inverse of 6 times sine of 45 degrees, and it is really important that I close the parenthesis after 45, divided by 6.4. And when I put this in the calculator, I end up getting that angle A is 41.5 degrees. So now all we have left to find is angle B. And if we go through this, I know that all 3 of my angles should add up to be 180. So I actually don't need to do any trigonometry to figure this one out. So I'm going to use the triangle sum theorem to help me out here. And I'm going to do 180 minus the other 2 angles that we know. And I end up getting that angle B is 93.5 degrees. So hopefully this is a good way just to double check if you know law of cosines, law of sines, and a way to know that all of our angles add up to be 180. So now moving on to part 2, and this is number 2 in that section, and it's asking us to find the area. So we're actually going to do numbers 2 and 3 because those are the 2 different types of problems we'll see. We know 2 different area formulas, and I'm going to go ahead and actually use the formulas. Remember, you could also use only one of them and find the information necessary by using law of sines and law of cosines. On number 2, I'm going to use Heron's formula, and I need to start by finding the semi-perimeter. So I'm adding 15, 8, and 10 together, and I'm going to divide by 2. And I get that the semi-perimeter is 16.5. So now I'm going to go ahead and substitute those values into our formula. So the area, which is K, is the square root of S times S minus A times S minus B times S minus C. Or the way that I normally put it into my calculator is by actually subtracting and finding those values. So now I'm just going to type in the square root and the product of these numbers and see what I get. And when I put that into my calculator, I end up getting 36.97 blah, 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 which ends up rounding up to 37.0 square units. It is important I label it because it is finding an area. So if we look at number 3, this time we're given two sides and then the included angle. And you guys may remember that we have a formula of 1/2 BC sine of angle A. And we said this angle had to be the included angle, which is the angle that's formed by these two side lengths. Or we really had to make sure, okay, whatever two side lengths I'm using, I need to use the other angle. So if I use side A and B, I would need to use angle C. So I'm going to go ahead and substitute this in. And then I need to go ahead and put that into my calculator. And I end up getting 9.1 square units. So based on the information given to me, I need to make sure that I'm using the correct area formula. The next thing we're going to look at are word problems. And I know I said this a few times in class, but the word problems on the test are very similar to what we're going to see on our review here. They're definitely not as difficult as the word problems out of the textbook. And we're going to go ahead and focus on number 1. So it says from a certain distance, the angle of elevation to the top of a building is 17 degrees. At a point 50 meters closer to the building, the angle of elevation is 31 degrees. Find the height of the building. So I went ahead and drew a little picture out. So here's my angle of elevation. Then 50 feet closer, we have another angle of elevation. And my goal is to find this height. Now, I think what makes this one kind of tough is that there is a lot of triangles. We have a right triangle here, we have a right triangle here, and then we have a non-right triangle. And I noticed that these two angles form a straight line so that their sum is going to be 180 degrees. So that angle ends up being 149 degrees. Now, since I know these two angles, I can find our third angle, which ends up being 14 degrees. Now, the reason why knowing these angles are important is because as of now, I don't have enough information anywhere to find this height. So my thought is that using this non-right triangle, if I can find this side length, then I know the hypotenuse for this right triangle, and we can go ahead and solve. So I'm going to label this x, and I'm going to go ahead and use law of sines to figure this out. Sine of 17 degrees over x equals sine of 14 degrees over 50. So when I cross multiply and divide, I end up getting that x is equal to 60.4 feet. Or I'm sorry, it should actually be meters. Let me try and fix that. Here we go. So 60.4 meters. Now I'm not done because we know we want to find the height here. So if I know this side, this is the hypotenuse, and off of our angle 31 degrees, this h would be our opposite. So I know that I'm just going to use this sine ratio. So I'm going to say sine of 31 equals h over 60.4. So I'm going to do 60.4 times the sine of 31, which equals our height, and I get 31.1 meters is equal to our height. So this is definitely the type of problem I would expect you guys to know how to do. I'm not going to go through any of the other ones, but hopefully having the answer key will help you out as well. But definitely just keep practicing, figuring out, should I use law of sines, law of cosines? Do I have a right triangle? Can I just use normal trigonometry? Moving on to vectors now, we're going to go through a few different vector problems, and I'm actually going to start by looking at number 1, which is asking us to find component form. So you guys might remember we need to do terminal minus initial to find the component form of a vector. So in this case, I would do 7, 3 minus 0, 10. There we go. And I would get 7, negative 7 as our vector. So what this is telling me is that it's moving to the right 7 and it's moving down 7. Next, let's take a look at number 3. We know this notation means the magnitude of vector v is 8 and the direction is 120. Okay, so if I'm just kind of looking at this, I know 120 is in quadrant 2, and we don't know the x or the y. Okay, and that's really what we're trying to find. We know this is 8, we know this angle is 120, and we learned a formula that the magnitude of v times the cosine is the x value, and the magnitude of v times the sine is our y value. So all I'm going to do here, I'm going to say 8 cosine 120, 8 sine of 120. And I'm going to go ahead and put that into my calculator. And I end up getting negative 4, 6.9. And if we look at this, it would make sense that our x is negative and our y is positive because it's moving to the left, and then it is going up. So that's just how we find the component form based on having the magnitude and having the direction. Moving on to number 5. Okay, they're giving us two vectors, vector u, which is 6, negative 5. Remember, we called this linear combination form, and to get it into component form, we just take those coefficients. And vector v is 10, 3. And they're asking us to find 2u plus 3v. So I'm going to have to do 2 times 6, negative 5, plus 3 times 10, 3. So if I'm going through this problem, I'm going to distribute, and I would have 12, negative 10, plus 39, which is 42, negative 1. So when we're dealing with these vector operations, we know that we can just use our normal distributing to each vector. So that's really what we did to get to this point. Then I'm going to add our x values together and add our y values together. Now I want to look at number 7, which is a unit vector problem. And we learned the way we do the unit vector is the vector divided by the magnitude. So number 7, the vector 7, 4. So the first thing I need to do is find the magnitude. And this is good practice for us. We know the magnitude squared equals 7 squared plus 4 squared. We're really just using Pythagorean theorem here. So I get the magnitude squared equals 49. 49 plus 16, which ends up being 65. And then I need to square root both sides, so I end up getting the square root of 65. Now, unfortunately, we can't do anything with the square root of 65. Okay, if I do a factor tree, it's just 5 and 13. So now we're going to have to do 7, 4, over the square root of 65, which is 7 over radical 65, 4 over radical 65. And we could also rationalize it and get rid of the radical in the denominator, and that would be another version of a correct answer here. Number 10 deals with the one formula that I'm giving you guys on the test, and that is cosine of theta equals the dot product of u and v divided by the magnitude of u times the magnitude of v. So that's given to you guys, but we do need to know how to find all of these different things. So the first thing I'm going to find is the dot product. Remember, the dot product means I'm multiplying the x values together plus multiplying the y values together. So I end up getting 12 plus 5, which is 17. Next, I'm going to find the magnitude of u. So I'm going to do the magnitude of u squared equals 3 squared plus 1 squared, which ends up being radical 10. The magnitude of v squared would be 4 squared plus 5 squared, which would be the square root of 41. So now I'm going to put all that stuff into our formula here, and I'm going to say cosine theta equals 17 over the square root of 10 times 41. And this is something that I can put straight into my calculator by using cosine inverse. And when I do that, I end up getting that our angle is 32.9 degrees. Okay, so just a reminder, this formula will be given to you. You need to know, how do I find dot product? How do I find magnitudes? How do I actually put this into my calculator? Looking at part 5, we're actually not going to do any of these because I think we've done a lot of vector stuff already. But I would definitely expect a lot of simple problems like these, where you are finding dot product, you're finding magnitude, you're doing just basic vector operations. So make sure you guys feel confident on this page. The final thing I want to talk about is just the concept of orthogonal. And I know that we talked about this in class, but remember, things are orthogonal if their dot product is 0. So that definitely will be on our test as well. So my hope is that you guys all do amazingly well on this test. Keep studying. I think the content is pretty straightforward. And definitely come in and ask me if you guys have any other questions.